Center for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson on graphing trigonometric functions. In our last lesson, we learned how to sketch the graphs of sine equations. Today, we will study the graphs of cosine function equations. Let us get started, students. In our last lesson, we learned that when we change the function y equals the sine of x to y equals a times the sine of x, we simply multiply each value of y by the value of a and change our graph accordingly. The same is true of the function y equals the cosine of x. The value of a becomes our new amplitude, and our graph expands or compresses in the vertical direction. The period does not change, but if a is less than 0, the graph will be reflected in the x-axis. Here we see the graph of y equals cosine of x. When we draw the graph of y equals negative 3 times cosine of x, the line begins at negative 3 and moves upward to an amplitude of 3, but the period is still 2 pi. The period remains the same, but the graph is stretched vertically. You might suspect that moving the variable to the x value, as in y equals the cosine of k times x, will result in a change of period. If so, you are correct. The cosine function behaves in the same manner as the sine function. Because cosine and sine share the same period 2 pi, we can use the same equation to investigate the effect of k. To find the period of y equals the cosine of k times x, we use 2 pi over k. If k is less than 0, we use its absolute value. Students, please look at this graph. Can you define the equation of the function that this graph represents? Write down your answer now.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello again, students. I am sure you did not find that too difficult. Firstly, we know that this is a graph of the cosine function and not the sine function, because the graph of a sine function starts at 0 and goes up. The graph of a cosine function goes down to 0. Since the amplitude is 3, we know that the value of A is 3. We can also see that the cycle repeats twice in the period of a normal cosine function. So this gives us our k value. Our function equation should be y equals 3 times the cosine of 2x. Was that your answer, students? Good work. Let us move on to the function y equals a times the cosine of k times x plus b in brackets plus c. You should recall that c and b become phase shift values. We change the equation so that it looks like this. If the value of b over k is less than 0, it will shift x in a positive direction. If the value of b over k is greater than 0, x shifts in a negative direction. If the value of c is less than 0, it will shift y in a negative direction. If the value of c is greater than 0, y shifts in a positive direction. If k times x plus b varies from 0 to 2 pi, then we determine that the value of x varies from negative b over k to negative b over k plus our period of 2 pi over k. In order to draw our graphs, we determine the period, the amplitude, and the phase shift, which is also the point where the line crosses the x-axis. Students, please draw the graph for one cycle of the function y equals 2 times the cosine of 2x minus pi. Indicate the amplitude, period, and phase shift.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello, students. Please compare your graph to this one. We will start with the graph of y equals cosine of x. The amplitude of the function is 2, so our graph stretches vertically. The period of the function is 2 pi over 2, which equals pi. This means that the entire cycle takes place within pi. The phase shift is pi over 2. You can see on the graph that the peaks of the curve occur at negative pi over 2 and pi over 2. The height or amplitude of the graph is 2. Let us try one more activity. This time, students, we will work backwards. Please look at this graph. You are given a period of 4 pi, an amplitude of 2, and a phase shift of 0. Can you determine the equation of the cosine function that is represented by this graph?
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. I hope